Hey guys, Mr. Antonucci here, and don't stress out about the AP Calc exam. This video is going to help you with Unit 1 limits and continuity, and we're going to go over a bunch of multiple choice questions as well as free response questions. So let's jump in. Before we get started on the actual questions, just want to take a second and talk about some quick facts about Unit 1 in the AP exam. It counts for about 10 to 20% of the questions you'll see. You have a 45 multiple choice questions total. That's half the exam, and the other half is 6 free response questions. That's the other half of the exam. You are allowed to use Desmos in the calculator on some of the sections, but there is no formula sheet. Let's look at some practice problems here, starting with multiple choice questions. So if we look at this one, the graph of f is shown here. Which of the following statements is false? So if we look part A, f of 1 equals the limit. Basically, that's the definition of continuity, and the function is continuous here. The function value at 1 is 3. The limit is also 3, so that's not false. F of 2 equals the limit as x approaches 2. Well, f of 2 is 4, while the limit from the left and right equals 2. So this is our correct choice. At x equals 2, you do have a removable discontinuity. You can just make the graph continuous if you are allowed to plug that point up. And there is a jump discontinuity at x equals 4. This one we want to investigate the limit as x approaches -2. Your first line of attack is to directly substitute -2 in. However, that makes the denominator 0. Since we have polynomials here, we should first start by trying to factor. The numerator factors into x plus 3 times x plus 2 over x plus 2. Factors of x plus 2 cancel, so you have x plus 3, and you take the limit as x approaches -2 for that, and you get +1, which is choice C. So here we have a piecewise function. For what value of k is f of x continuous at x equals -2? Remember, for continuity, the function value has to equal the limit value. So the function value at -2, you would use the bottom piece. That's going to be -2 squared is 4 plus k times -2 is -2k plus 3. That's going to give you 7 minus 2k. The limit as x approaches -2, since -2 is the part where it splits, you're going to have to investigate the limit from the left and the limit from the right. So from the left, you're going to use the top piece. That would be x plus 5. So that's going to be -2 plus 5 is 3. And then from the right, you're going to use the bottom piece, which is going to be x squared plus kx plus 3. And when we plug in -2, you would get 7 minus 2k. For the limit to exist, the left and right limits must be equal. So 3 has to equal 7 minus 2k. And then we solve for k, subtract 7, divide by 2, you would get, or excuse me, divide by -2, you would get k equals 2, which is choice D there. How many removable and non-removable discontinuities does the graph of y have? Now you have to be careful here because we have polynomials, so you could have some factors in the denominator that either make removable or non-removable discontinuities. So this quantity here, this quadratic, if it factors, we want to factor it, and it does. It factors into x plus 2 times x plus 6, factors of 12 that add to 6, or add to 8 rather. So you have the factor x plus 2, x plus 6, and x minus 3. The factors of x plus 2 would cancel, which indicates one removable discontinuity. So we have B and D. And the factor of x plus 6 and x minus 3 in the denominator here, both would make the denominator 0 when the numerator is not 0, and that would be a non-removable discontinuity. So our correct choice here is D. Here, if the limit as x approaches 3 from the left is 2 and from the right it's 4, which of the following must be true about f of x? F of 3 equals 2, that's not necessarily true because we don't know. B, as x approaches 3, the limit exists. That's false because the limit from the left and right are not equal, so the overall limit cannot exist. f of x is not continuous at x equals 3. This is true because the left and right behavior are different. And D is false because it's not a removable discontinuity. To have a removable discontinuity, the limit from the left and right would have to be equivalent. For which of the following does the limit as x approaches infinity equal 0? Well, this one, the limit is going to approach infinity because the degree of the numerator is greater. So it's not that one, which we can immediately eliminate choices C and D. Number 2, as x approaches infinity, this expression would approach 0 because e to the x always grows faster eventually as x approaches infinity than any polynomial function. It's probably going to be 2 only, but we'll want to check just to make sure to eliminate 3. The limit for this one is going to equal 1 because the degree of the numerator and denominator are the same and the leading coefficients are both 1. So you would get a limit of 1. Let f be a function that is continuous on the closed interval from 1 to 3 with f of 1 equal 4, f of 3 equals 10. Which of the following is guaranteed by the intermediate value theorem? Remember, the intermediate value theorem says that if a function is continuous on a closed interval, the function is going to pass through all the y values between the endpoints. It's guaranteed to do that at least once. So f of 1 equals 4 and f of 3 equals 10. So if I do 1, it's like has this point, and then it has this point up here at 10. So this would be 1 comma 4, and this would be 3 comma 10. I know that the graph is connected, but I don't know how it connects between these points. But I do know that to get from a y value of 4 up to a y value of 10, it has to pass through all the ones in between. F of 2 equals 7 could be true, but it's not guaranteed because we don't know the specific value at 2, so that's not true. F of x equals 2 has at least one solution. Well, that's not necessarily true or guaranteed. It could be, but we only know that it has to pass through the y values from 4 to 10, which 2 is outside of that range. C, f of x equals 8 is basically saying the function has got to hit the y value of 8 somewhere on the interval from 1 to 3. This one is true, so it's guaranteed by the intermediate value theorem. So that automatically eliminates D. If the function f is continuous for all real numbers and f of x equals x squared minus 1 over x minus 1 when x is not equal to 1, then f of 1 is, so you have to be careful with this one because f of x, the x squared minus 1 over x minus 1 is undefined when x equals 1, but this says that you're only using that when x is not equal to 1, and we know that f is continuous for all real numbers. So it's not going to exclude any values. So what we want to do is take the limit as x approaches 1 of the function, and that's going to be the limit as x approaches 1 of x minus 1, x plus 1. The x minus 1s would cancel, and you'd have x plus 1. So the limit as x approaches 1 of x plus 1 is 2. So we would have to define f of 1 as being 2 in this case. And for this one, for which of the following does the limit as x approaches 4 exist? Remember, for the limit to exist does not mean that the function actually has to hit the same value exactly at 4. So this graph right here has a limit as x approaches 4. It exists. This one does not because you have a jump discontinuity, so the left and right limits are not the same. And the third one here, the limit as x approaches 4 also exists because you have the same behavior from the left and right. So that's graphs 1 and 3. That wraps up our multiple choice review. Now we're going to jump into some free response questions. Here we go. Let f be the function above where k is constant. For what value of k, if any, is x continuous at x equals negative 2? Justify your answer. Now we did one like this in the multiple choice questions, but here, since this is free response, we have to make sure that we're showing the right justification. The first thing we need to do, if it's continuous at x equals negative 2, we need to get f of negative 2, which you would use this second piece here. Negative 2 cubed is negative 8, and negative 8 plus 2 is negative 6. Then the limit as x approaches negative 2. Since negative 2 is the point where the pieces switch, we would have to look at the limit from the left and the limit as x approaches negative 2 from the right. As you approach -2 from the right, you're going to use that second piece there again. So that's going to be -6. From the left, you're going to use this top piece. Now, as x approaches -2, if you plug -2 into all of that and simplify, you would end up with 2 minus 2k over 7. So for the function to be continuous, those two need to be equal to one another. So 2 minus 2k over 7 equals 6. And then we solve that for k, and you would get k equals 22. So part B, what type of discontinuity does f have at x equals 0? So we have to look at the limit from the left and the right to determine what kind of discontinuity this has. So the limit as x approaches 0 from the left, we would have to use this second piece again. So that's going to equal 2. And the limit as x approaches 0 from the right, values greater than 0, we're going to use this last piece here. If you plug 0 into that, you would have 2 over 2 minus 1, which is 2 over 1, which is 2. The left and right limits are both 2, so that means that the overall limit as x approaches 0 is 2. Now we just have to see what f of 0 is. F of 0 is 0. So since the limit does not equal the function value, but the limit exists, you have a removable discontinuity. So you would have to say that in a complete sentence, because the limit as x approaches 0 of f of x equals 2 and f of 0 equals 0, f has a removable discontinuity at x equals 0. Part C, find all horizontal asymptotes, show the work that leads to your answer. In order to get a horizontal asymptote, you need to take the limit as x approaches positive infinity, which would be this last piece is what we're going to use. So we take the limit of 2e to the x over 2 minus e to the x. At infinity, we would have e to the x going off to infinity, and then the denominator would also grow with e to the x. The 2 here wouldn't really make any difference at infinity. But since the denominator's e to the x is being subtracted, it's going to make the limit approach -2. Then you have to take the limit as x approaches negative infinity, which you're going to have to use that first piece because that's valid when x is less than -2. We take the limit as x approaches negative infinity here. Since the numerator and denominator have the same degree and they're both an even power, as you approach negative infinity, they're going to cancel one another out, and the limit is going to end up being the ratio of the leading coefficients, which is going to be 1/3. Our next one here, the graphs of f and g are shown on the interval -3 to 5. The graph consists of line segments except where f of x equals that function there on the interval 0 to 2. Write a difference quotient that best approximates the instantaneous rate of change of g at x equals 4.5. Here's the graph of g. 4.5 would be right about there. Basically, we just need to get the slope. Since it's a line segment, we can do g of 5 minus g of 4 all over 5 minus 4. If you put the actual numerical values, it'd be -1 minus -3 over 5 minus 4. You don't have to actually simplify it the whole way because it just asked for the difference quotient. It didn't ask for the actual value there. Part B, let h of x equal g of f of x. Find the limit h of x as x approaches 4. Use the correct notation in your answer. Part B, let h equal g of f of x. Find the limit as x approaches 4. Use correct limit notation in your answer. So if we want to take the limit as x approaches 4 of h of x, we would have to do it from the left and right. If you look at the graph of f, as x approaches 4, the graph of f approaches 2, but it approaches 2 from below 2. So this is going to be equal to the limit as x approaches 4 of g of f of x. And this is going to be equal to the limit as x approaches 2 from the left only of g of x. Again, because as x approaches 4, f of x is approaching 2, but it's only approaching 2 from below 2, from the left of 2, so to speak. And if you look at the graph of g, as x approaches 2 from the left, the limit is equal to 1. You wouldn't also have to approach it from the right because f of x is only approaching 2 from values less than 2. Now let's jump into part C. Let k of x equal f plus g. Consider -1, 2, and 4. At which one of these values does k have a jump discontinuity? Justify your answer for the jump discontinuity using correct limit notation. Let's first start with x equals -1. You are going to have a jump discontinuity here. If you take the limit as x approaches -1 of k of x, that's going to be the limit as x approaches -1 of f plus g. So the limit as x approaches -1 of f from the left is 0, and g as x approaches -1 is -1. So that's going to be 0 plus -1, which is -1. The limit as x approaches -1 from the right of k, which is the same as from the right of f and g, that's going to be, for f, you're going to approach 1. And for g, you're going to approach 1 also, which gives us 2. Since -1 is not equal to 2, then you would have a jump discontinuity because the left and right-handed limits exist, but they're different. K would not have a jump discontinuity at 2 or at 4, and we could look at the same left and right-handed limits. So here we have a piecewise function capital F. The amount of money raised during a fundraising campaign is modeled by the function f defined above, where f of t is measured in United States dollars and t is the time and days since the campaign began. Part A, find the limit as t approaches infinity of f of t. Explain the meaning and context of the problem. So the limit as t approaches infinity of f of t, if we let t approach infinity, we would have to use this bottom piece here. And since the numerator and denominator have the same degree, the limit is the ratio of the leading coefficients, which is 800 over 1, or 800. Now, I'm not going to write this out, but the interpretation would be as time increases, the amount of money raised during the fundraising campaign approaches $800. Next, we want to know, is the function continuous at t equals 7? So remember, we have to look and make sure the limit is equal to the function value. So f of 7, we would have to use the bottom piece, which is 800 times 7 minus 4,800 over 7 minus 4. And if we evaluate that, we would get 800 over 3. Now we have to look at the limit. So the limit as x approaches 7 from the left, we would have to use the top piece, which would be 2 to the 8th minus 2, which is going to give us 254. So since 254 is not equal to 800 thirds, the function is not continuous. Part C, the amount of money raised during a competing fundraising campaign is modeled by the function M, defined by capital M of t, where that's measured in United States dollars. T is the time in days since the campaign began. According to this model, is there a time t for 0 to 2 at which the amount of money raised is $10? So what we could do is note for part C, M is continuous on the interval 0 to 2. That's important because we're eventually going to use the intermediate value theorem. M of 0 is going to be equal to, if we plug 0 into this function, you would have 0. M of 2 would be 240 times 3 over 40, which is 18. Now, you would say, by the intermediate value theorem, there must be at least one time in the interval 0 to 2 such that m of t equals 10, since 10 is between 0 and 18. All right, guys, that's it for this review. Remember, you got this. Make sure you review often, practice daily, and walk into that test with confidence. Make sure you like, comment, and subscribe for more review videos.